Hey there, my name is Alejandro, and welcome back for day 162 of me doing the Daily LeetCode Challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for December 25th, 2024. Merry Christmas for all of those that celebrate. And without further ado, let's get straight into the problem. Ho, ho, ho. Okay, today we got LeetCode Medium, problem 515, find largest value in each tree row. Seems like we've solved this problem before. Let's look at submissions. This was solved July 2nd, 2024. So this was before the Daily LeetCode Challenge. All right, let's see. Given the root of a binary tree, return the array of the largest value in the row of the tree. Okay, given the root of a... Return an array of the largest value in each row of the tree. So for each level, return the maximal value. Okay. Yeah, it's going to be super easy, especially compared to previous day's problems. But essentially, you just want, like, for each level, we know how to get, an array of all the nodes in a level. Instead of an array, just keep track of the max, right? So here we'll have, like, levels is equal to a default dict of int. And are all the values... all the values can be negative. Okay, so we should do a dictionary. And here we'll do q is equal to collections.deck of, here we'll say root, comma, level 0. So this is a node and its level. While the length of the queue is greater than 0, not 9, 0, here we'll say node, comma, level equals q.pop left, pop left. I wonder if we could specify default value, right? Because it would be nice if the default, if I do default dict of int, can I do like default equals 0, -4 or something? Print f string levels of 1 equals, and here we'll do return an empty array, right? What if I did something like this? Yeah, this doesn't work, right? Yeah, yeah, since the node values can be negative, we don't want to do a default dict of 0. Or we can just do, okay, levels of level equals max of node.val and levels.get that level's value, and by default we'll do float of -infinity. Okay, there we go. And so yeah, so we do the maximum between the current node's value at that level or the current value at levels, and if there isn't any, we do float of -infinity to essentially say node.val, right? Or here we could do node.val by default, right? So here, and we'll say if node.left, then q.append node.left. If node.right, then q.append this with the next level, level plus 1. And here we'll do max level equals 0. Node dot max level equals max of max level and the current level. Node dot right and level plus 1, and then he'll say for return an array, a list of levels of level for level in range. We'll start with 1 all the way up to max level plus 1. Okay, so accepted the very first try. Let's submit this. Num.tate object has no attribute val. Oh yeah. Yeah, so if here we just need to do if not root, return an empty array. That's the only possible case that can screw us. Okay, now we can submit. And there you go, bada bing, bada boom, completion streak 162 days, consistency is key, see ya tomorrow, ho ho ho, Merry Christmas ladies and gentlemen. Okay, thankfully for December 25 on Merry Christmas, LeetCode was like, all right, we'll give you a chill problem for all you homies out there. We won't overly kill you this time. Okay, I respect that. They gave us a really hard problem for Christmas Eve, but for Christmas itself, here is LeetCode's Christmas present. You just get a nice, easy medium. So thank you, LeetCode, for making Christmas Day a LeetCode miracle, right? So thank you for that. Okay, nice. Yeah, this is a very straightforward problem. So I guess I'll just get straight into the solution and explanation. So without further ado, as always in all my videos, I do a quick recap of how I was able to solve the problem. So for this one, this is rather simple, right? So essentially for every single level, right, or row or whatever you call it, or depth or whatever, we essentially want, out of all the nodes at that essentially a level, the one with maximal value, right? So, one way you can do things is essentially like you can do a level order traversal of the binary tree, so BFS. But the point is essentially for every single node, I'm going to essentially keep track of that node as well as its level, right? And what I'm going to do is I'm going to start off with root, and then I'm going to say like, okay, we're going to keep adding elements to this queue. And so what I'm going to do is while the length of the queue is greater than 0, we're going to pop a node and a level from the queue, right? At the very beginning, it'll be the root node, which is at level 1, right? So level 1 over here, right? And here we have a dictionary levels, right? Which essentially maps a level to the maximum value in that level. So as you can imagine, at the very end, we'll essentially get the maximal level ones, right? So here we can probably do if level greater than max level equals level. Yeah, this is fine. Okay, we can submit again. I wanted to make this a little bit faster. So, okay, now we're at 8 ms. Really? Interesting. Okay, 7 ms. What? Okay, so I guess it did not like that. Okay, we were at 3 ms and so on, but yeah, I wanted to see if we could get to 0 ms runtime. Seems like we might not be able to. Maybe if I did like a DFS approach and so on. Okay, let's keep going with the solution explanation. Essentially, like I start off with a very root node at level 1. Essentially, I'm gonna keep popping elements from the queue as long as it's not empty. I'll grab that node in that level. Obviously, my maximum level, I'll set it to the maximum of the current maximum level and level. The reason we'll do that is because at the very end we need to know like how many levels are there for us to essentially print off the values. And then what we will do is yeah, here we could also do a list and so on, but yeah, for now I'll just explain the solution and then we'll do some optimizations. But essentially it's like, yeah, we get that node in that level. Essentially, if that node has a left value, then we're gonna append that to our queue, and if it has a right value, then we'll append that to our queue, right? If it's not none. But when we append it to our queue, when we add like node.left to our queue, we must remember, like if we're at a node, like for example the root, its left and right children are one level deeper than that current node, right? So if this is at level k, these guys are at level k plus 1. These guys are at level k plus 2 and so on. So when we add a node's children to the queue, we need to do so with level plus 1, right? And then the magic sauce is whenever we take a node and a level from the queue, we're going to say, hey, okay, we're going to go into a dictionary at levels, at level inside of levels. Essentially, it's like, this maps essentially level to the maximum node value inside of that level. So here, we'll update it to either be the maximum between the current node's value and the current maximum value at that level. If there is nothing in that level at the moment, then by default, we say float of negative infinity. That way, we essentially make node of val, right? Node of val will always be bigger than float of negative infinity. But otherwise, another thing we can do here is like, by default is equal to node.val, right? And so yeah, so here we get the current maximum value at levels at the key level, right? Or by default float of negative infinity, just so we have a super low value. And then between the current value there, or float of negative infinity by default, and the current node's value, will make levels of level the maximum of these two, right? Because for each level, we want the maximal value node at that level or at that row, right? So every single time we pop a node, we have its level. We will update that level to essentially be the maximum between that current node's value and the current maximum at that level, right? And now whenever we exhaust all the nodes at the very end, then essentially we know we have the maximum value per level. How many levels are there? Well, we kept updating this max level variable, so we know it's going to be between 1 all the way up to that max level inclusive. And there we go, bada bing, bada boom, we are done with the problem, right? And here we can for level, I think dictionaries are ordered by default in Python. It's not something you should rely on for hash maps, but I think if we did something like this, technically it will be correct. You could do levels.values, if anything. Maybe we have to convert this into a list. Yeah, so maybe we do a list of this, right? But then we can get rid of this, we can get rid of this, and that way we do things a little bit faster. Right, so yeah, so in Python it's just convenient that dictionaries are sorted in order by default, but yeah, it seems to not affect the overall runtime complexity, right? But otherwise, like, you know, hopefully that solution made sense in terms of, like, you know, you essentially just do a level order traversal. Each node has a level. When you add its children, it'll be that level plus 1, and then for every single time you pop a node from the queue, you have its level, update the maximum levels value at that level to be the maximum between the current value there or the node's current value, and there you go, right? That's pretty much it. But yeah, okay, I'm kind of annoyed the fact that we're so slow. So if anything, maybe we will make this an array here, right? And here, level, otherwise, then return levels. Can I do something like that maybe? Levels equal to length of levels. At the beginning, there's nothing. Then yeah, levels that append node.val. Sorry. There we go. All right, so something like this is accepted. So maybe now it's a little bit faster. Okay, so now we're at 100%. There we go. 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 So yeah, so instead of using a dictionary, yeah, so I'm being a little bit cheeky. I'm using the exact same idea. It's just that since I'm doing a level order traversal, right? Essentially, I can be confident that I'm going to go through the levels in order, right? So it's like I'm going to do level 0, or like, you know, like essentially the way that I'm going to traverse a tree is in BFS. I'm going to do this row first, then this row, and so on. So then I'm like, okay, you know what? Essentially, whenever I come across a new level, then I'm going to augment the size of my levels array. Otherwise, I'm currently at the same level, right? So I only want to look at whatever's in the last value, right? So here, for example, like at the very beginning, I have root with level 0. And so if the level is equal to the length of levels, then it means it's like, okay, I just entered a new level, right? So starting with the very first one. So then I'll append, you know, node.val to my levels array because it'll be the very first value that I see at this level, right? Otherwise, if this is not the case, then it's like, okay, my current level will be, you know, the very last index in levels, right? So the very last index in levels, I could also do, you know, levels at, if I did this should also work, right? Yeah, so that should also work. The point is that, like, you know, so essentially, instead of using a hash map, essentially the index is the level itself, right? And so obviously, if the index equals the length of levels, that means I'm entering a new level. So I need to append the array by 1, so that way level is a valid index inside of levels, right? Otherwise, so like, if anything, maybe this would make you more comfortable. Why? While a level is less than length of levels, then levels that append, you know, node.val, right? So maybe that'll make you feel a bit more comfortable. Oh yeah, I can't put an else in a while, right? Right, and then it's like, you know, I could do something like this. Greater or equal, that's what I mean. right? And then that would be accepted, right? So technically you could do something like that, but the point is like, I know that since I'm doing a level order traversal of the tree, I won't have to do that, right? Because like, I'll only augment by one level, right? I'm gonna go through this node, then this node, then this node, and then this node, this node, this node, and so on. But I won't DFS, I won't see 5 before I see 2, right? I'll see 1, then I'll see 3 and 2, then I'll see 5, 3, and 9, and etc, and etc, etc, right? So that's why I don't need a while loop. But if you were really paranoid, right? And by the way, here I can put like, any value I want, like -1, right? The point is that this sets the value correctly right here. Yeah, so instead of doing a while loop, right, I just recognize the fact that like, hey, if level is equal to length of levels, then I just need to append 1, and I know that levels is the valid index, because here I could just do the very last one. That's where it'll be, right? But yeah, if you're really paranoid, you can use a while loop, right? But that way, instead of using a hash map, even though everything is still O of 1, that way I'm using an array, so it's just like that tiny little bit faster, so that when I submit my solution, I get it to be like a little bit faster, and that way I get that. Oh no, I'm a 3ms now. Okay, submit again. We gotta get that. For Christmas, we gotta get that 0ms solution. It's just a must. No! What's going on? What's popping? Yeah, no val or it's gonna be the max between these two. Maybe we do an elif here. Oh, come on, you can't give me 1ms. That's crazy. You can't do this to me. Okay. One more submit. Believe. There we go. 0ms beats 100%, so that's exactly what we like to see, right? But again, the idea is completely the same. It's the very same algorithm and so on. Instead of a hash map, I'm using an array and so on. But the point is like, essentially, go through each node, keep track of its essentially level or depth, and then like, have some data structure, whether you use an array or a dictionary. Dictionary is just very convenient. That way you can make the levels the keys themselves. That way it's like, the value is just whatever maximal value is of that at that level, right? And if anything, you could do a DFS way to do this thing, right? So here you could do a def DFS, all right? And here you could take in a root node and be like, okay, if not root, then return, right? And here's like, here you have a dictionary, right? And here we'll say depth equals 0. Here we'll say DFS with root.left, DFS with root.right, and then it's like d of depth, right? Or here we can do level is equal to max of the root.val as well as d.get the value at level, and by default we'll just do float of -infinity, right? Just to disincentivize that solution, right? And then here's like we can do printf string d equals here, and then just return let's say an empty array, right? And then here, like here we're doing a depth research. We're not doing a level order traversal, but here we'll see we get the same exact values, right? Okay, here just in case, I'll just do this, self.d, so that it just knows what I'm talking about, because it's being a little annoying here. Oh yeah, this is also y. Yeah. In fact, I don't think I need to do this. The problem here is, okay, we'll still do it just in case. Okay, whatever. Here we need to pass in level +1, right? And here level +1. Right, and okay, so it's being annoying, so we'll do self.d, right? But here I'm just trying to illustrate a point, basically. Bro, really? Oh, wait, no. What? Oh, I never called DFS. Oh my gosh, I need to do DFS from the root. Yeah, okay. So now if I call my DFS function, okay, I'm being dumb. So yeah, now if I call my DFS function, you'll see like, okay, you know, level 0, for example, or here, you know what, we'll just make things more concise. Again, Python dictionaries, they preserve ordering, even though that's technically not supposed to be something that's true about hash maps. But here we'll say, hey, the maximal value inside of level 0 is 1. The maximal value inside of level 1 is 3. The maximal value inside of level 2 is 9, right? So that's kind of the point. And then, you know, you can just return all those values in the way that you want, right? Here we can return like, you know, self.d.values here. And here we'll see that, like, you know, we get an accepted solution, right? Okay, as a list because it's annoying, but nevertheless, the point will be proven, right? And so yeah, so there you go, right? So it doesn't matter whether you do a level order or like, you know, a DFS type of approach. DFS, BFS doesn't really matter. But when you do it in BFS like I did, essentially you don't really need that while loop. You can just use a levels array like this, and then it's just like, okay, if level is equal to length of levels, you know that you're entering a new level, so then append that node value. Otherwise, you know, it's like, okay, levels at the next level is equal to node.val, and that way you're just able to return levels at the very end, right? But the essential general core concept of how to solve this problem remains the same, right? Essentially, traverse through the tree for each node, make sure you know what level it's at, and then it's like, okay, have some data structure, array or dictionary. Dictionaries are just happen to be very convenient. Just append, you know, the maximal value at that level based off, like, you know, the node that you're looking at and the current value that you have for there. And then at the very end, just return, you know, the maximal value for each level in sorted order, and then bada bing, bada boom, there you go. That's how you solve this problem, right? So hopefully that solution made sense. And yeah, for Christmas, nice to get that 0 mess beats 100% solution. Just absolutely beautiful. So there we go. So hopefully that solution made sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I catch you in the next one. So for now, Merry Christmas, my friends. Ciao, ciao.